Good evening, ladies and gentlemen. My name is Ethan Wyatt, and today I'll be presenting my process project on a thing called monosodium glutamate. Here's the table of contents of what I'll be going over today. First things first, what is monosodium glutamate? Who made it? Why is it important? Next, Chinese restaurant syndrome, also known as CRS. How much is produced and how it's made. What is monosodium glutamate? So, monosodium glutamate, most commonly known as Msg. It is the sodium salt of glutamic acid. It is most commonly used as a flavor enhancer in food, and it gives the sensation of the taste umami, which is a savory sort of taste. I like to compare it to the taste of like pot roast or a good soup or things of that sort. It is naturally found in foods such as tomato and cheese, not Msg itself, but glutamate. It's speculated to be the cause of Chinese restaurant syndrome, also known as CRS. And right there, you can see its molecular formula. And there's a little picture down there at the bottom right here. And you can see the glutamate, which is C5H8NO4, and then the sodium, which is Na. So monosodium, one sodium, and then you have the glutamate right here. 1, 2, 3, 4, 5. Yep, all there. So who made it? Msg was not actually made, but it was discovered by a chemistry professor by the name of Kakune Ikeda in 1908 in Japan. He discovered it in seaweed that was used for cooking. So at the time, lots of chefs in Japan, they used this specific type of seaweed to enhance the flavor of their food to give it a more robust, strong, savory flavor. So Mr. Ikeda here was curious. He wanted to know, how did the seaweed give this food that flavor? So he went home, sorry, and he studied it. And when he was studying it, he isolated a molecule called glutamate. And he found that glutamate gave the food that savory flavor. And he gave that flavor a name. The name is umami, the umami taste, the savory flavor. So Mr. Ikeda got right down to business, and he started to mass produce it and sell it under the brand name of Ajinomoto in Japan, which is one of the biggest brand name sellers of Msg worldwide. Why is it important? As stated before, it is a taste enhancer like salt and pepper. So salt gives you a taste of salty, pepper gives you a taste of spicy, and Msg gives you a savory taste. It contains about 2/3 less sodium than table salt, so a third of the sodium that table salt contains. Because of this, it can be used as a salt replacement. This is important for those who need to watch their salt intake first if they have certain conditions or things of that nature. Also, high salt intake is a major contributor to cardiovascular disease, which is also a major problem in the U.S. A good number or a good percentage of the deaths that occur in the U.S. are from people who had cardiovascular disease, and it might not be related, but the disease definitely also took a toll on their health as well. So replacing salt with Msg could help reduce sodium intake, which in turn could reduce cardiovascular disease in the U.S. and reduce the people dying from it, so on and so forth. It is only a good thing. Now, Msg is, not Msg, sorry, glutamate is also the most abundant amino acid in the brain. And what this amino acid does is that it works as a neurotransmitter. So neurotransmitter, it transmits information to different parts of the brain and different parts of the body. And glutamate is also found to be helpful in memory and learning as well. Now we're going to talk about the phenomenon known as Chinese restaurant syndrome. It is described by some as symptoms felt after eating Chinese food. It's not an official like sickness, it's just a collection of symptoms. And these symptoms include weakness, sweating, headache, chest pain, just to name a few of the symptoms that these people feel. For no reason at all, Msg was pointed to be the cause of all these symptoms. People just pointed to it for some reason. However, this was proven not to be true, and to this day is still being proven to not be true. Now, at the time, a doctor named John Olney did an experiment on mice where he injected them with Msg, and then these mice experienced brain seizures. Basically, their brains just went haywire, off the walls, everything. But he was using quantities that were so large it was unrealistic. The quantities were he used 4 grams per kilogram of body weight. So for a normal human to consume proportionally the same amount, they have to consume 300 grams of MSG. That is a lot of MSG. And it's just unrealistic for a person to consume that much MSG. It said right here, ingesting 3 grams of MSG without food may produce mild symptoms in a very small number of people. And these people usually have a hypersensitivity to the glutamate, means that they are allergic to it. Now, we consume about 0.55 grams of MSG per day, but we consume 20 to 40 times more naturally occurring glutamate than MSG. So just this figure alone debunks a lot of things said about MSG and how it has a negative effect on your health. It can only have a negative effect on your health, first, if you're allergic to it, or if you consume 300 grams at once, which no one should be doing. And if you're doing that, I'm concerned for you. As you can see, glutamate is found in many foods we eat, such as eggs, cheese, tomatoes, and potatoes, and it is the main component of monosodium glutamate. So all this hysteria coming about because of MSG is just unfounded. There's so much research pumped into this proving it wrong, but people still want to believe that MSG is bad for you. What was bad is all the xenophobia and racism that occurred because of this phenomenon. Chinese restaurant syndrome originated from Chinese restaurants, was run by Asians, so a lot of racism against the Asian community, attacks, and other things like that came to be because of this hysteria about MSG, and that really affected society and how Asians were viewed at the time. And also because of this, businesses shut down. The Asians at the time just experienced a lot of problems, and you can see like sort of thing kind of happened with coronavirus as well. Although it's not really relevant, but these types of things happens when false information is spread through false science. There's no real science to back this up, but I'll move on. Now we're going to talk about how much is produced. About 4.7 million tons is produced worldwide as of 2018. This chart is from 2015, but this is just here for reference to show that the volume is steadily going up over time. So the demand is increasing, and so is the market for it. More is being sold. Asia is responsible for about 94% of that production. So basically, all the production is coming from Asia, and most of it is coming from China, which between 60 and 70% of production, and also about 60% of the consumption as well. Now, the U.S. is responsible for less than 1% of production, which is about 47,000 tons or less, and they import way more than they produce. Now, we're going to get to how it is made. On the right is just have some references. And first reference, hydrolysis is a process where water is used to break down molecules. Fermentation is the breaking down of sugar molecules into different substances. A centrifuge is a device that uses centrifugal force to separate parts of a solution. A cool way to explain that is if you have a ball and a stick and you spin the ball around, the force that you feel like pulling out at you is the centrifugal force. And a centrifuge uses that force to separate different parts from a solution. Now, this process can use sugarcane sugar, sugar beets, or molasses as well. I just chose cassava because that's just what I chose. I found interesting, but it's replicated using all these different things as well. So you start out with cassava. Cassava is a tuber similar to a sweet potato that is found natively in South America. The cassava is then peeled and boiled, and this is important because cassava itself is toxic to humans. It contains a lot of cyanide in its raw form, so it has to be prepared properly because cyanide is very toxic to humans. It leads to death and a whole bunch of other health complications that you do not want. So the cassava has to be peeled and boiled, and while it's peeled and boiled, it is also grinded into grind into a pulp. So it then travels into a centrifuge, and then the pulp is separated from the starchy liquid. And the byproducts of the pulp is the tapioca milk residue, so any like milk that's within the pulp, tapioca thipi, which is basically the pulp itself, and then the starch waste. And the main use of these byproducts typically is for animal feed. So that's it. So what you get from that process so far is tapioca starch. And then the tapioca starch undergoes hydrolysis using enzymes. So the tapioca starch is carbohydrate, and the carbohydrate most found in the tapioca starch is sucrose. So when it goes under hydrolysis using enzymes, they take an enzyme to turn that sucrose into sugars. And the sugar that they turn it into is glucose, and they turn it into glucose using an enzyme called A-amylase typically. So the A-amylase takes in the sucrose, breaks it down into the sugar glucose. So once you get the sugar glucose, it then undergoes a process called fermentation. Said before, fermentation is breaking down the sugar molecules into different substances, and it's broken down by fermentative bacteria. So there's specific bacteria to break down sugar into different things. So the one used to break it down into glutamic acid is Corynebacterium glutamicum. So that bacteria, it takes in the glucose as energy, and then it turns it into glutamic acid. Now the glutamic acid is an amino acid, and they're all linked together, bound to different amino acids and proteins as well. So in order to separate them to get the free glutamate that you need, in order to make MSG, it goes under another hydrolysis process. Now this hydrolysis process is different. It's because hydrochloric acid is added to make it acid hydrolysis. And acid hydrolysis uses the hydrochloric acid to separate all the amino acids linked together into separate ones. So they're all their own individual one. And that's how you get the free glutamate in order to make MSG. So now it's by itself and isolated. So once that process is over, it then goes under neutralization. So the neutralized solution, you add acid. Now they're going to add in a base. The base, sodium hydroxide, NaOH. So now you have an acid-base reaction going on. And in that acid-base reactions, they produce a salt and they produce water. So the salt, sodium, and then produces water as well. So it comes together to create monosodium glutamate. So the salt is added to the glutamate, and the other product is water as well. So then, now that you have the MSG, but now it's dissolved into the solution. So right now it's dissolved into the solution, and the solution is not clear at all. So the solution has to get decolorized, and it's decolorized to add activated charcoal, also known as carbon, and they use a gravity filter. So they add it to the solution, and then the activated charcoal, it takes the color out of the solution through a gravity filter. And gravity filter, self-explanatory, the solution comes down through the filter, and then the color leaves the solution. So once all the colors out of the solution, it then has to get crystallized. So it's crystallized through evaporation. So the water in the solution is evaporated, leaving behind little crystals, but there's still some water left in the solution. So crystals are starting to form, but there's still water inside the solution. So then it has to get removed. Almost always through a centrifuge. Filtration isn't used as much anymore. So it's mostly a centrifuge, and the centrifuge, as I said, spins it around, separates the crystals from the water. The crystals are still wet, so the crystals have to be dried, and then you get your refined MSG crystals, which are packaged and sold for you. Conclusion, big conclusion, MSG is not bad for you. Don't be scared of it. And I hope you learned about a food additive today. Hope you take something away from this. Thank you for your time, and you have a good one.